Second time in history, a man-made object has left our solar system.
NASA recently shared some really big news about Voyager 1, a space probe that's been cruising through space for 45 years. They found something that scientists thought was impossible. This discovery is shaking up what we know and sparking lots of talk among experts. It's like a whole new chapter in our understanding of space, showing us there's still so much we don't know out there. But before we get into the cosmic nitty-gritty, let's rewind to 1977. Picture this, a historic launch from Cape Canaveral, Florida, propelling Voyager 1 into the depths of space. 15 days later, its twin, Voyager 2, joined the party. Their mission? To explore the gas giants, Jupiter and Saturn, and their entourage of moons. Little did we know, they were destined for a journey that would defy expectations and rewrite the rules of space exploration. Fast forward to today, and these intrepid explorers have outlasted every spacecraft in history, venturing farther from Earth than any human-made objects. We're talking interstellar space, baby, beyond the sun's sphere of influence, into the uncharted territory of the galaxy, where no man-made object had gone before. Now that's what we call breaking records. But wait, there's more. In the last 45 years, Voyager 1 and Voyager 2 have been the gift that keeps on giving. Their early observations of Jupiter and Saturn's moons were mind-blowing. Forget what you thought you knew about barren moons. These bad boys were teeming with geological activity. Surprise, surprise. Voyager 2, the overachiever of the duo, swung by Uranus in '86 and 3 years later, did a flyby of Neptune. No other spacecraft has dared to tread that path. Talk about the ultimate cosmic road trip. Now let's get to the juicy part, the impossible discovery. What are our Voyager buddies up to? Well, strap in because it's a shocker. Despite having a memory capacity that makes your old flip phone look like a supercomputer and a speed slower than your grandma's Wi-Fi, these spacecraft have become the space detectives we never knew we needed. Recently, scientists received data that left them scratching their heads. Io, one of Jupiter's moons, isn't the dull, lifeless rock we thought it was. Nope. Thanks to Voyager's keen eye, we've discovered towering volcanic plumes and eruptions that put Mount Everest to shame. Imagine Pell, one of Io's volcanoes, going off 30 times higher than Everest. That's like fireworks on steroids. And guess what? Voyager's instruments picked up peculiar signals from Io, confirming the wild discoveries. But the adventure doesn't stop there. NASA's been working its magic to keep these space pioneers going. Over the past 3 years, they've been conserving energy, turning off non-essential components and heaters to extend the Voyager's operational lifespan. It's like giving your old car a tune-up, but instead of a road trip, it's a journey through the cosmos. As we edge closer to 2030, the estimated mission end date, there's a bittersweet feeling among the scientists and engineers who've been on this interstellar roller coaster since day one. The Voyagers weren't just machines. They were our eyes in the sky, capturing the wonders of the cosmos with a precision that would make any photographer jealous. Our twin Voyagers have been cosmic detectives, uncovering surprises since their launch. One of their greatest hits was dropping the knowledge bomb that Jupiter, the gas giant, is rocking some faint rings. Rings around a planet. Now, that's a game changer. It added a whole new layer of intrigue to the already mysterious Jupiter. And let's not forget Europa, one of Jupiter's 53 named moons. Voyager 2 spilled the icy tea that Europa's got a shell thicker than your grandma's winter coat, a whopping 60 miles thick. This shattered our previous assumptions about distant moons and got scientists buzzing about potential alien ice parties. Now, as the Voyagers bid farewell to Jupiter, they got a gravity assist, a cosmic high five, if you will, propelling them toward Saturn. Without this boost, they'd be stuck in the sun's gravitational clutches like a bad breakup. But thanks to that slingshot move, they embarked on separate adventures. Voyager 1 took a detour close to Saturn's mysterious moon Titan. Picture an orange, hazy atmosphere and scientists going, "What's cooking in Titan's cosmic kitchen?" Voyager 1 then flipped north, leaving the planet party behind, and headed straight for the edge of our solar system. Intergalactic highway, here we come. On the other hand, Voyager 2 had its blockbuster moments. In '86, it pulled off a historic flyby of Uranus, discovering 10 new moons. Talk about a moon jackpot. 3 years later, Neptune was in the spotlight, and Voyager 2 was there to spill the beans. Wind speeds of 1,000 miles per hour, an azure methane-rich atmosphere, and a moon named Triton that's colder than your ex's heart. Voyager 2 laid it all bare. Now let's talk about the unsung hero, Carl Sagan. This cosmic maestro, part of the Voyager imaging team, fought tooth and nail to capture a parting shot of Earth before shutting down the cameras. On Valentine's Day in 1990, Voyager 1 snapped the iconic pale blue dot. It's like the cosmic equivalent of a postcard from the edge. Earth is a tiny pale blue speck from 3.8 billion miles away. Goosebumps, anyone? But here's the kicker. These space marvels are rocking an 8-track tape system. Yup, you heard it right. The 70s are alive and well in space. Picture this. 2 brave spacecraft, Voyager 1 and Voyager 2, embarking on a cosmic quest to explore the outer reaches of our solar system. But here's the twist. They needed a boost, a turbocharge beyond their engines. Cue the gravity assist maneuvers, the cosmic choreography that turned these spacecraft into celestial dance partners with the heavyweight planets of our solar system. So, what's this gravity assist jazz all about? It's like a cosmic slingshot where the spacecraft steals some of a planet's momentum as it zooms by. Voyager 1, for instance, pulled off this mind-boggling move with Jupiter. Imagine the precision. The spacecraft approaching at just the right angle and speed, Jupiter's gravity giving it a boost. But let's not kid ourselves. This maneuver is an art. Approach Jupiter at the wrong angle, and it's cosmic chaos. The scientists and engineers behind this celestial ballet got it right, not just once, but multiple times. These gravity assists propelled the Voyagers on a breathtaking journey through the solar system, like a grand tour guided by the universe itself. Voyager 2 even used gravity assists from Jupiter and Saturn to swing by Uranus and Neptune. Now let's talk about the unsung hero of this cosmic opera, the Deep Space Network, DSN. Think of it as the interstellar telephone line that kept us connected with our Voyager probes. While these spacecraft were out there exploring, the DSN's colossal antennas in California, Spain, and Australia were our lifeline. The Voyager probes were our eyes and ears in the vastness of space. But to make sense of the data they sent back and give them new instructions, we needed a cosmic megaphone. That's where the DSN stepped in. Picture this. Voyager 1, on its way to the outer reaches of the solar system, sends a message back to Earth. It's a faint signal, weakened by the cosmic journey. But fear not. The DSN's colossal antennas catch that whisper and amplify it for us to decode. The Deep Space Network, DSN, is the unsung hero, an interstellar telephone line connecting us with our farthest out space buddies. It locks onto Voyager's feeble signal, turning it into data for scientists to analyze. As Voyager 1 heads to Ophiuchus and Voyager 2 ventures toward Cetus, the question lingers, what's next? Some predict a cosmic death in 2030, but these cosmic explorers might outlast us all, enduring for millions of years, potentially encountering other star systems, carrying a message from a long-lost Earth. Don't forget to hit that subscribe button, give us a thumbs up, and share your thoughts in the comments below.